all the received signal over CAN. Are those signal correct? Shall we use those signal or not? Guys, is it clear? So now, if we'll talk, we have torque sensor. Okay. So 3 channel of torque sensor are used. Okay. Why 3 channel are used? Let's say if one channel is not working, then out of 2 other channel, your ECU will get torque input. Understood? If let's say 2 channels are not working, only one channel is working, that is also not correct. One channel is working, then immediately ECU will detect it's a major fault and that ECU will go into fail safe. So for giving that time, if 3 channel of sensor are used, that means if one channel is not working, at least 2 channel out of 2 channel, that ECU can perform its task. Understood? For the safety reason. If let's say, if we'll use only one channel of torque sensor, and if it's fail, then what will happen? Will completely will not get torque related sensor input. Got it, guys? Understood now? For safety reason, we are using multiple channel of same sensor. So now we have 3 sensors, 3 channel of torque sensor. All 3 channel are responsible to calculate how much driver is applying the torque. I mean, let's say it will do the average. Let's say channel 1 is calculated 2 Newton meter of torque. Channel 2 calculated 2.1 Newton meter of torque. And channel 3 calculated 2 Newton meter of torque. So it will take an average of 2. Now let's say if this channel 2 is failure, then depending on channel 1 and channel 3 input, it will take as a sensor input that ECU will take. Guys, are you understanding this? Now we
Yes,
have
sir.
angle sensor. Okay, so 2 channel of angle sensor used. Okay, coarse and fine. Fine angle and coarse angle. Okay, so angle also we are using 2 channel sensor. Fine angle and coarse angle. Both will calculate, and based on both, will calculate how much driver wants to rotate the wheel. Understood? So now let's assume there is a failure observed. Okay, there is a failure observed in channel 1. Okay, this channel 1 is not working. Then ECU will always monitor, or we can say perform test. Okay, it will run a test. Channel 1 working or not working, channel 2 working or not working, channel 3 working or not working. Angle sensor, fine angle sensor is working or not working. Coarse angle sensor is working or not working. It will run a test. And based on the test, it will validate. If let's say channel 1 is not working, then ECU will detect there is a fault in channel 1. And when channel 1 is failure, then ECU will detect it. So after detection, what it will do? It has to store that information. So it will trigger a fault named torque channel 1 fault will set to true. The ECU. Understood, guys? Guys, have you understood this? The ECU will continuously run the test. Okay. When the test failed, that means that particular thing is not working. There is an issue. Okay. If there is issue detected, then that issue has to be captured in ECU and it will trigger a related fault. Let's say ECU detected there is a failure in channel 1. Then the ECU will set a variable. This is also a variable, torque channel 1 fault. This variable will be set to 1. This indicates there is a failure observed in channel 1 sensor of torque. Guys, understood?
Yes,
Hello?
sir.
Understood, na? What about others?
Understood, sir.
Yeah. So when this failure is observed, it will set this variable torque channel 1 fault to true. Okay. Now it is set to true. That means the failure is there, but that failure has to be matured. Then only ECU will store DTC related information in the memory. Okay. So that depends on maturity time. Okay. Maturity time, what do you mean by maturity time? The time taken by fault to confirm whether that fault is there or not there. So let's say the maturity time of low voltage, actually this sensor related fault maturity time is considered as 0 millisecond. Immediately, if little bit also, because these are very critical, okay. If ECU detect for 0 millisecond, if it detect there is a fault in channel 1 or channel 2 or channel 3, immediately that data will be stored in the form of DTC in memory, because these are critical faults and critical faults are handled at runtime immediately. Understood? So the maturity time will be considered as 0 millisecond. Whenever the fault related to critical faults detects, immediately the DTC will be stored in the memory. Guys, have you understood? For some non-critical fault, there can be maturity time. Let's say for voltage, for low voltage fault, okay, maturity time 500 millisecond. Understood? So now, if the maturity time is 500 millisecond for low voltage fall, and if the ECU detected low voltage, if voltage is less than 9 volt and it stays for 500 millisecond, okay, then store BTC related information in the NVM, non-volatile memory. Guys, understood? Hello? Have you understood? But for this fault, immediately, if sensor 1 fault is detected, store DTC related information in the NVM because there is no maturity time. Guys, clear? Hello? Guys, is this clear?
Yes, sir.
Everyone?
Yes, sir.
Yes, sir.
Okay. Now, based on this criticality, okay, based on criticality, there are in few projects you will see faults are categorized in 4 levels. Okay. Level A, level B, level C, and level E. Okay. Level A are not that much critical fault. Okay. Like mostly related to CAN faults. Those are critical, but okay. If this data is somewhat correct or not correct, still your ECU will work. Okay. So those are categorized as level A fault. Level B faults are mostly related to hardware sensors fault. Or okay, like if sensor channel 1 is failure, that will be tagged with level B fault. Level B are critical fault, very critical fault. If this fault is there, your ECU will not work. Understood? Level C are mostly related to memory. If memory got corrupt or memory got erased or something, some tune related plausibility fault, those are categorized as level C fault. Level C are also considered as critical fault. If level C faults are there, still your ECU will not work. Understood? And level E are just events. So events means if let's say a level B fault, sensor channel 1 fault is there. So level B fault will trigger and level E fault, there is event of torque sensor failure event will also trigger. So these are just events. Okay. Understood? Mostly these A, B, and C level faults are tagged with DTCs. They will have some DTC assigned. Not all A level fault, but B and C level fault mostly will be there, tagged with DTC. A level fault, some faults are tagged with DTC number. Guys, understood?
Yes, sir.
Others understanding now? So based on the criticality of fault are categorized in 4 levels. Okay. See, that depends on the project. Some project does not follow this label convenience. Sorry. Understood. Some projects will not follow this label categorization of fault. Some projects they follow. They will categorize A level, B level, C level, and E level fault. So out of I told now 400 to 500, 600 faults are there. Those faults will be categorized. Level E faults are events. Those are like those events will come with some other fault. This just show there is an event occurred. Okay, let's say torque sensor failure event, low voltage event, high voltage event. So along with low voltage fault, low voltage event will also trigger. Along with sensor 1 failure fault, torque sensor failure event will also trigger. Understood? So once a fault is matured, then only that information will be stored in DTC. Understood, guys? As of now, at least understood about fault, what is maturity time? Because see, using 19 service, we are going to read DTC information. Okay. So DTC information, first we need to understand when this DTC diagnostic trouble code information will be stored. Then only using 19 service, we are going to read what all faults are there in the memory. What all fault information are stored in the memory. Using 19 service, we are going to read those information. Understood, guys?
Yes, sir.
Everyone, is it understandable?
Yes, sir.
Any difficulties? Anyone? Please do let me know. Any difficulties? Okay, fine. So now we'll start faults. Sorry, 19 service. Now, is my PPT visible?
Visible, sir.
Yeah. Now we'll see this. Okay. So now we are going to see this. Read DTC information service, that is 0x19, 19 service request. Okay. Okay. So this is the service we are going to see. So this service allows the client to read the status of server resident diagnostic trouble code information from any server or group of server within a vehicle. Okay. So this service request is used to read the status of server resident diagnostic trouble code information. Server resident diagnostic trouble code information means whatever the information is stored in the memory of server. Using this service request, we are going to read that DTC information from the memory of server. Okay. So now what all things this 19 service will provide us? So this service allows the client to do the following. Okay. What this service allows the client to do? Retrieve the number of DTCs matching a client defined DTC status marks. Okay. So what does it mean? Retrieve the number of DTCs. So let's say paint screen visible. Now let's say we have DTC 01, 0A, 03. We have DTC 03, 01, 08. Okay. And third DTC 04, 05, 0. Let's say, as I told, DTC information will be of 3 byte. This 3 byte will tell what DTC this is. And by seeing this number, let's say this is related to voltage, low voltage fault. Low voltage fault. So now low voltage fault is mapped with this DTC, and when we'll see this DTC means by seeing manual we'll come to know this DTC is logged because of low voltage fault. And now let's say this DTC is for torque sensor failure. Okay. And this DTC is for vehicle speed fault. So now these three information are stored in the memory. Understood? This is the scenario. Guys, these three DTCs information are stored in the memory. Now let's say retrieve the number of DTCs. If we'll talk about this point, retrieve the number of DTCs matching a client defined DTC status mask. That will mean that means it will give how many DTCs are there in the memory. So now how many DTCs are there? We know, right? There are 3 DTCs stored in the memory. So by using 19 service, first we can able to read how many number of DTCs are there in the memory. Now retrieve the list of all DTCs. Means what are the list of DTCs? List of DTCs means this number. First DTC is this is 1, this is 2, this is 3. So these 3 numbers will read which DTCs are stored in the memory. First, we can retrieve how many numbers of DTCs. So we know there are 3 numbers of DTCs stored. Now, which all those? So we can retrieve even DTC's number. Okay. Now retrieve the list of DTCs with a particular functional group matching a client-defined DTC status mark. So we can retrieve the list of DTCs with a particular functional group, means related to sensors, related to angle, related to some hardware failure. So which particular functional group DTCs are there, we can get the list. Understood? Now the fourth point is retrieve all DTCs with permanent DTC status. So we can retrieve using 19 service what all DTCs are supported for the project. Retrieve all DTCs with permanent DTC status. So using 19 service, even we can retrieve what all DTCs are implemented in the project or supported in the project. List of DTCs. Let's say 30 DTCs are implemented. So we'll get which all DTCs are implemented in the project. Understood, guys? Guys, are you able to follow me? What about others?
Yes, sir.
Okay, na? So we can retrieve all the DTC with permanent DTC status. Okay, that will go in detail once we'll go to subfunction. Now, each point specifies one subfunction. Using one subfunction, you can able to read number of DTCs. Using one subfunction, you can able to read list of all DTCs matching the client-defined status mark. So these all are related to subfunctions. So we'll go subfunction in detail. Don't worry. Okay. Now this fifth point is retrieve DTC snapshot data. Okay. This snapshot data is sometimes referred as freeze frame associated with a client defined DTC. DTC snapshot are specific data record associated with a DTC that are stored in the server's memory. Okay. So now let's say, is my paint screen visible? Guys? Guys? Is my pen visible now? Now, this is just listen carefully. This is very important point. Okay. Whenever a TTC is stored, okay, this TTC will be stored when the low voltage fault condition was detected by the ECU and this fault condition matured. Got it, guys? When this DTC information will be stored in the memory? When the ECU detects a fault condition. Correct? Correct now? And when that fault is matured also understand? For a certain time duration, that fault should be there. Then that fault will be called as matured or confirmed. Understood? Yes or no? When a fault is matured, then only DTC information will be stored in the memory. Okay. So this DTC number will be stored in the memory of server. Now, along with this DTC, status byte information. Okay. Snapshot, record information, or freeze frame record. Extended data record information will also be stored. Okay. Along with this DTC number, the status byte information. What is the status of this DTC? This status byte we'll see in detail. Don't worry. About this DTC, what is the status? What is the current status of the DTC? Will be stored. Snapshot record information or freeze frame record information. So what do you mean by snapshot record? When a DTC is stored, okay, when this low voltage fault was detected, or let's say a sensor fault was, let's say this, we'll consider about this, okay. When a torque sensor failure detected, when this failure was detected by the ECU, what was vehicle speed at that time? Okay. What was the voltage of ECU at that time? What was the current of ECU at that time? What was the temperature of the ECU? Okay. What was column torque value of the ECU? What was the driver angle request? What is the yaw rate? Okay. Along with DTC, these all information will be also stored. Okay. As a freeze frame or a snapshot. A snapshot, you know, right? In the PC, we'll take a screenshot. That is a snapshot. Understand, na? So what we'll do? If you want to store some information, you will take a snapshot of that data and you will store as a snapshot record. Here, when the DTC is detected or the fault condition is detected by the ECU and this DTC is matured, along with the DTC, status byte information and a snapshot record information. Record information when the DTC was logged. What was the vehicle speed? What was the voltage? What was the current drawn by the ECU? What was the temperature? These data, these are just an example. Apart from that, other data also can be there. Okay. These are just a generic example I have given. That also will be stored in the memory. Immediately the ECU will take a snapshot, means when the DTC was logged, what was the value of this value? It will take a snapshot and will store in the memory. Why this is required? Can anybody tell? Let's say in the future, if a developer wants to analyze what is the reason this fault has happened, by seeing this snapshot record, he can able to analyze. Understood? When the vehicle speed was 180 kilometer per hour, at that time, suddenly the column torque increased. Then because of that, the torque sensor got failed. Guys, are you able to understand me? Okay. So for later analysis, these snapshot record are important. Now, take a live scenario. A car manufacturer has launched a new car. Okay. And when the new car is in the market, customers are complaining like whenever they are going on high speed, they are detecting some kind of a failure. Okay. Maybe the power steering is getting failed. Now, how does now this failure was reported by so many people. So many people detected the similar failure. Now, how do the company, the OEM, will come to know what is the reason why this failure is happening again and again? In that case, once initial analysis will be performed by seeing this data. When the vehicle speed was 180 and when the temperature was this, then when the column torque was this, then this fault was happened. So it is easy for them to reproduce the fault in the lab. Okay. In the lab, once they will again create the same scenario, they can able to see that fault. Understood now? For reproducing the fault, some critical parameters which are stored in the form of a snapshot record with the DTC number. By seeing this, they can reproduce the fault, right? Correct, huh, guys? So this information is important for analysis. When the developer or when the R&D center, when somebody is or engineer is analyzing what condition trigger this fault, in that case, this snapshot data record is very important. Understood? So using 19 service request, even we can able to read this snapshot record data. Okay. Using 19 service, if you want to read the snapshot record, you can able to do that. For whatever the DTC, let's say we took the example, right? We took example like these two DTCs are stored. So same snapshot record or additional snapshot record will be stored for this also, this DTC also. So if you want to read the snapshot record of this DTC, you need to send. I want to read a snapshot record. The client will send request for this DTC. I want to read. Then this snapshot record it can able to retrieve. If it want to read for this DTC, then it has to send. I want to read this DTC snapshot record. Then the server will send a snapshot record of this DTC, and there will be separate memory where this snapshot record will be stored. It's not like this DTC and this DTC both are sharing the same memory to store a snapshot record. No, there will be separate snapshot record for this DTC. There will be separate snapshot record for this DTC. When this fault was logged, what was the value of these parameter? It will be stored under this DTC snapshot record. Guys, have you understood? Hello? Guys? Susan? Please tell. Have you understood? Not understood. Guys,
Yes, sir.
everyone, have you understood?
Yes, sir.
Don't say for the sake of saying. Have you understood or not? I want true answer. Have you understood? Guys, everyone, have you understood? Okay. So this snapshot record will be separate for all the DTCs and it will be stored in the memory. Whenever client wants to read or retrieve the DTC snapshot record information, it can retrieve with DTC number. Okay. It has to send, client has to send for which DTC wants to retrieve the snapshot record. Got it? Yes, now? Guys? Now, along with snapshot record, there will be extended data record also stored for each DTCs. What does extended data record mean? Apart from snapshot record, some additional data will be also stored, like occurrence counter. Like aging counter or self-healing counter. These are additional information stored in the memory for each DTC. What are those? Occurrence counter. How many times? This occurrence counter is nothing but it will say how many times this fault has occurred. Okay. Means how many times the fault is getting occurred and occurred and occurred. If let's say in a ignition cycle, when you turn on the ignition, you went for driving the car. In that case, the fault has occurred, like the low battery voltage fault has occurred. Then the occurrence counter of low battery voltage DTC will increment to 1. Next day again you turn on, again you went, again low voltage, battery voltage fault occurred. Then the occurrence counter will increase to 2. So by seeing this occurrence counter, we'll come to know, is it happen, let's say, the fault, low voltage fault happened only one time. And after that, 1 month, it didn't happen. Is it required to go for servicing? Not required, right? One time it happened somehow. After that, it never happened. Correct, na? Guys? Is it required to pay attention? Like you need to go to mechanic and check why this low voltage fault has happened? Because it occurrence counter has only one value. That means it's happened one. That also maybe some time back. Not required to check. Maybe somehow it got happened, but currently it is not there. By seeing occurrence counter, we can able to track how many times this fault has happened. If this fault has happened 200 times, this 200 ignition cycle, this fault was detected. Then definitely, if this fault is not there, still we need to check because it is happening frequently. Understood, guys? Yeah. And what do you mean by aging counter or self-healing counter? So like occurrence counter, there is a term self-healing counter or aging counter. Okay, I'll tell you what is the uh, idea behind it. Why this aging counter or self-healing counter has implemented in the project. Okay, so aging counter is, it will have a track, see how many ignition cycles this fault didn't happen. Let's say, take an example. Uh, let's say we turn on the vehicle, okay? We turn on the vehicle and we went for a ride. And there was low battery voltage fault detected, okay? Now, in this case, the DTC related to low battery voltage will be stored in the memory. So let's say 01, 03, 08, okay? This is the DTC for low battery voltage, and this will be stored in the memory. So now, as I told, for this DTC, snapshot record and extended data record will also be stored, right? Correct now, guys? Along with this DTC, snapshot data record as well as extended data record also will be stored in the memory. Okay. Now let's assume this fault happened only one time. Okay. One time somehow this fault raised. Okay. Now this fault is not raising for 2 months. Okay. Then is it required to store these snapshot record, all the data record for this DTC in the memory? Because it happened for only one time. After that 2 months, this fault never happened. Is it required to acquire memory? Memory is limited, right? Unnecessary, this is capturing some memory space, right? Yes or no? Guys,
Yes, sir.
just make a note. Okay, just make one note. This is important. Only 8 DTC information will be allowed to store in memory. Okay. Only 8 DTC information, that much memory is only there to store at a time. We have 30, 40 DTCs, but at a time only 8 DTC information only is allowed to store in the memory. If more than 8 DTCs are triggered, then low priority DTC will be erased from the memory and that DTC information will be stored. Maximum only 8 DTC information can be stored in the memory. In passenger vehicles, in cars. Understood, guys? Guys, have you understood? Okay. Now, let's say this low voltage fault was detected and it was stored in the memory. And now this DTC was not detected for 2-3 months. Is it required to store this DTC information in the memory? Because we have limited memory, right? We have only memory to store 8 DTC information, out of which this DTC is unnecessary stored in the memory. Understood, guys, my point? What I'm trying to say? Guys? Am I clear?
Yes, sir.
Yeah. So that's why this aging counter mechanism is implemented. Okay. This aging counter will capture for how many ignition on and off this DTC was not triggered. Means this fault condition was not there. So let's say we went for a drive and this low battery voltage fault detected. Then this DTC information along with snapshot record and extended data record will be stored in the memory. Now next day again, we turn on the vehicle, we went on a drive and this low battery voltage fault not detected. Then for this DTC, aging counter will increment to 1. Okay. We again came back home, turn off the vehicle, ate biryani and slept. Okay. Now next day again, we woke up, turn on the vehicle, we went off for the drive and this low battery voltage fault not detected. Then this DTC's aging counter will increment to 2. Likewise, it happened for 2-3 months. And in 2-3 months, 40 times we went for a drive and there was this fault not detected. Okay. For some project, 40 is the limit. Some project they are implementing 255. If the aging counter value reaches 40 or some project, it can be 255. Then this DTC related information will be automatically erased from the memory. Understood? Guys, when the aging counter value for a particular DTC, for this DTC, aging counter has reaches 40 or in some project it can be 255. That means this DTC is not triggered after first time this DTC was stored. After that, this DTC was not triggered for 40 times or 255 times. Then this DTC information will be erased from the memory to save the memory for other DTC to be stored. Understood, guys? So this aging counter or self-healing counter will track for how many ignition cycle the same DTC was not triggered. And if that DTC is not triggered for long time, 2-3 months, that DTC never happened. It is not required to store that information in the memory. Simply erase that. Maybe let's say after when it was erased, after again 1 month, again same DTC was logged. Then again the snapshot extended data record and DTC information will be again stored in the memory. Understood? Guys? Okay. Now one more important point. Now let's say this aging counter increases to 30. Okay. And our threshold is 40 to remove DTC information from memory. Now, after once the aging counter reaches 30, again, when we went on the drive, this DTC was logged. Then what will happen? Guys, the aging counter was 30, but it didn't reach 40. If it will reach 40, then this memory will be erased from, this DTC information will be erased from the memory. But when the aging counter was 30 and we went on the drive, again, this low voltage fault was detected. Then what will happen? This aging counter value will be reset back to 0. Okay. And from 0 again, it has to increase and go to 40. Understood? Everyone, did you understood my point?
Yes, sir.
This very important point. In the interview, definitely they will ask. If they will ask 19 service, they will ask about extended data record, occurrence counter, and self-healing aging counter. What do you mean by self-healing counter or aging counter? What do you mean by occurrence counter? This is very important. And they may ask this question. If let's say the aging counter is 30 and our threshold is 40 to remove the DTC information from the memory. But when the aging counter is 30 and the ECU again detected that DTC fault, then what will happen? Then the aging counter reset back to 0, and from 0 again it will start counting till 40. Understood? Now again, let's say it again reaches to 38 and again this DTC was detected. Then again from 38 it will reset back to 0. Guys, understood?
Yes, sir.
Guys, everyone? What about girls? Understood?
Yes, sir. Understood.
Everyone, have you understood?
Yes, sir.
Okay. So using 19 service, now we'll come to the PPT. Understood now? This is snapshot record and extended data record. Guys? Okay. So in snapshot record, different parameter record will be stored like voltage, ECU temperature, ECU current, or vehicle speed, what is the engine status, what is the ignition state. So many parameters will be that depends on OEM. That list will be given by the OEMs. Okay. OEMs will give whatever snapshot record for each DTC has to be stored. They will tell. We are not writing code of our own. Based on the customer requirement, we will develop. If customer will say only voltage, vehicle speed, and engine status to be stored, we will write code to store only these 3 snapshot records. If they will ask us to store 15 parameters, maybe different, we will write code to store those 15 snapshot records. Understood? So that depends on the OEM. If OEM is telling what all snapshot or extended data record has to be stored, we will develop code accordingly. Is it clear, guys? Okay, fine. Then we'll go to next. So retrieve DTC extended data associated with a client defined DTC and status mask. So we can even retrieve extended data records also. Okay. So what does this extended data records have? Malfunction indicator counter, which conveys that the amount of time or number of engines operating hours during which the OBD system has operated while a malfunction is active. So like I gave example of occurrence counter, self-healing counter. There may be malfunction indicator counter also implemented. Okay. So this will give for how many hours that engine was on and that malfunction was active. Okay. Now, the second point, DTC occurrence counter. So as I told, counts number of driving cycles in which test failed has been reported. Understood? So occurrence counter means how many times that DTC occurred in the driving cycle, means ignition on and off. The third point is DTC aging counter. Counts number of driving cycle since the fault was latest failed, excluding the driving cycle in which the test has not reported. Okay. Time of last occurrence, etc. So these data will be stored as part of extended data record, and using 19 service, we can retrieve it. Is it clear, guys? Guys, is it clear these points?
Yes, sir.
Everyone, is it clear, right? Okay, we'll go next. So these are the important terms. Okay, we will see. So one point is enable criteria. So what do you mean by enable criteria? Server or vehicle manufacturer criteria used to control when the server actually performs a particular internal diagnostic. So enable criteria is nothing but when the server is going to perform the test. See, for capture a failure, first server has to perform or ECU has to perform the test, right? So this enable criteria tell when the server is actually going to perform an internal diagnostic. That is enable criteria. Understood? Guys, like let's say every 100 millisecond, it will run a test to check all the sensors are correct, all the power supply received are correct, all the actuators are correct. Understood? So the enable criteria there is every 100 millisecond, automatically server will run the test. Understood? Or in some of the ECU, which are non-critical ECU. So whenever the ignition or whenever the power on is done, that time it will run a test one time. That's it. It will not again and again run the test. So for that, enable criteria is ignition on. Guys, understood? No? Enable criteria. So see, enable criteria is when server is going to run the test to identify failure. That is called enable criteria. So in some issues, critical issues, that run will be automatically done by the server every 100 milliseconds. Okay, every 100 millisecond, ECU will check whether the sensor are working fine or not, all the hardwares are fine or not. So for that ECU, what is the enable criteria? 100 millisecond, because the server is running that test every 100 millisecond to check, right? That is the trigger point for internal diagnostic. Understood? Guys? Okay. So now, let's say if we'll talk about a non-critical issue, when they let's say wiper or side mirror, okay, or door mirror. So whenever the ECU is powered on, those issue are not critical issue. Okay, in the middle of driving, if there is some fault in that ECU, it will doesn't affect much. So for those ECU, enable criteria is whenever powered on, that ECU will run a test to check all parts are working fine or not. So for those ECU, the enable criteria will be powering on ignition. Understood? So that is mean by enable criteria. Guys, understood? So, guys, understood?
Yes, sir.
Okay. Now, what do you mean by test pass criteria? So when the server will run a test, and if the test is okay, like It run a test if the sensor value is correct or not, or if the vehicle speed value received is correct or not. If the test is pass, that is test pass criteria. Understood? So it run a test and the test is pass. That is test pass criteria. Got it? And test failure criteria is when a ECU run a test and the test is failed. Let's say ECU run a test, what is the value of voltage? Okay, received from the external power supply. And the value of voltage is 8.3 volt. The test is failed because it should be minimum 9 volt. The value is less than 9 volt. So the failure criteria is the voltage received from the external power supply is less than 9 volt. That is the failure criteria. Understood? And the pass criteria for it is if the voltage is greater than 9 volt and less than 16 volt, that is the pass criteria. Guys, understood? Guys, please speak up. Have you understood? Yes, no? Not understood? Is it going above head? Shall I stop for today? Guys, is it going above head? Yes, no? Yes, sir? Okay, then we'll see tomorrow then.